Hello, welcome to CSIR, Building and Road Research Institute, Civil Engineering Laboratory. I'm Dennis Ajo, Chief Technical Officer. In this lab, we conduct tests on cement, concrete, blocks, and other building materials. You are welcome once again. We'll take you through some illustration on the work that we do here. Thank you.
I'm a technical officer in the civil lab, and I'll take you through some of the equipment we use here. This is the Geotechnical apparatus, which is used in compaction of cement mortar. It uses a 3-game mold. That's a 40 by 40 by 160mm mold in the test. It has a main switch and a drop counter, as well as a start and stop button. There's also a mortar mixer, which is used to mix sand, cement, and water uniformly. This is a Vickers apparatus. This is a Vickers plunger and a Vickers mold. This is used to test the consistency of cement paste to determine the quantity of water needed in a cement paste. This is a snitch hammer or a rebound hammer. This is used to test the strength of concrete. It's normally used in the field as a non-destructive testing machine to test the strength of concrete. This is an ultrasonic pulse velocity machine, which is used to test the quality of concrete. So it tests the velocity in an ultrasonic pulse passing through the concrete. And we go through the concrete resistivity system. This is a concrete resistivity machine. That's an electrical resistivity machine. It tests the electrical resistivity of a concrete and also the resistivity of chloride ingress in concrete, as well as carbonation. This is an elastic modulus machine or tester, which is used to test the elastic deformation resistivity of a concrete. Thank you.
Hello, I'm a technical officer in this laboratory. We have in the laboratory a laboratory furnace, which is used for calcination of samples and also heating samples to a specified temperature before we run our test on it. The capacity of this furnace is 1200 degrees Celsius. So after heating to that temperature, we cool it and then mail it to a certain final that we want, then we use for our test. We have the BRRI apparatus here, which is used for the soundness test on cement. So after mixing the cement paste in the laboratory with the mixer, you fill the BRRI apparatus molds with the cement paste and then you cure for 24 hours before you heat the sample. Then you determine the expansion of the cement paste. We have a water bath also here for heating our samples to a temperature of about 100 degrees Celsius. We also have in the lab the rapid chloride permeability test equipment used for determining the ingress of chloride ions in concrete samples. So before you run the test, you have to first saturate the samples to make sure that the concrete sample is well saturated, and we use our vacuum saturation machine here, where first a dry vacuum is created in the concrete sample, then water is replaced, air is replaced with water in the concrete samples before we remove it for the test. So this is our test host, and then our cells which we use for the test. The test involves passing currents through the concrete sample for 6 hours and then calculating or determining the charge, the total charge that passes through the concrete. Then you classify the concrete based on the charge that passes through the concrete. We also have an automatic mechatronic which we use to determine the certain time of cement. So after mixing the cement paste in the mixer, you fill the mold and then you insert it here. Then the machine will automatically penetrate through the cement paste, after which, based on the standard, the initial setting would be calculated when the needle makes a penetration, or when the distance between the base plate and then the base of the needle is 6 mm. And then for the final setting time, when the needle makes a penetration which is about 0.5 mm. So it should be less than or equal to 0.5 mm before we classify the cement paste to be hardened. We also have a length comparator here, which we use to check the drying shrinkage of mortar bars, and also we use it for our alkali silica reactivity test also. For tests that involve drying of samples, we have a laboratory oven which we use to dry our samples. Some of these tests include the grading of aggregates, water absorption of mortar bars or concrete, subtility, suction. You need to dry your samples before you use them for the test. So we have an oven that we use to dry the samples before we carry out our test. We have a digital blend fineness apparatus which we use to determine the fineness of powder like cement, glass, ceramic. The fineness of the powder determines the reactivity of the material. So with this machine we can determine the fineness of that material, the specific surface that can react with, say, water. In instances where concrete samples are supposed to be brought to the lab for various tests to be carried on them, we have a coring machine which we use to pick samples from site. That's if there is a structural member and we want to conduct tests on them, we have the coring machine that we use to bring those samples to the lab for the test. So this is the motor that drives our baits. We have a 50 mm diameter bait, a 100 mm diameter bait, and then a 150 mm diameter bait for picking concrete samples from the site.
My name is Engineer Bernard Kusu, and I'm the head of the Geotechnical and Materials Engineering Division. Here at the Geotechnical and Materials Engineering Division, our primary mandate is to conduct geotechnical investigation on proposed site for civil engineering projects. When I talk about civil engineering projects, I mean roads, buildings, dams, landfills, any civil engineering project. Somebody will ask, why do we do geotechnical investigations before the construction of these civil engineering structures? All civil engineering structures are founded on geological materials. And because these geological materials are not the same, they have some inherent properties that are different from one another. So the aim of the geotechnical investigation is to unravel these geological factors that are likely to affect these structures before, during, and after construction. Some of these factors may be high groundwater table, which is the cause of building dampness that we witness in most of the buildings in our community. Another one is expensive materials that may cause differential settlement leading to building cracks. Another one also is deleterious materials like high pH, sulfates, and chloride content that are likely to affect concrete. That will lead to building collapse. So these are some of the factors that we unravel when we conduct geotechnical investigations. And one aspect of geotechnical investigation is laboratory testing. What laboratory testing do is to characterize the soil that we pick from the field. Once you are able to characterize the soil, be able to determine the appropriate design for the structures that we want to construct. And here at the Building and Road Research Institute, we have an ultra-modern geotechnical, computerized geotechnical laboratory with comprehensive equipment for testing all the soils for geotechnical analysis. So at this point, I will take you to the equipment that we have for the various tests. This is the odometer or the consolidation equipment. This is used to determine parameters for settlement. This equipment is a triaxial equipment, and we use it to determine CM5. And it also is used in bearing capacity calculations, shear strength, which is also used in embankment design and construction. And here we do all the three triaxial tests. That's the unconsolidated or drain, unconsolidated drain, then the consolidated drain. And this equipment one up here. Yes. This is a ADU that allows us to capture all the lab tests that we did real time. Once the lab test is going on, this equipment captures the data and transmits it into the computer. So all the results that we get here are all captured in real time. Another one that we have is also the direct share. That is also used to determine the CM5 of sandy soils. That is also used in embankment design. So this equipment here is called the California Building Ratio equipment, or simply CBR equipment. And this is very important in road design because the CBR is used in calculating the thickness of the various pavement layers that is used in the road construction. So we use this equipment to determine the CBRs of materials that are used in the road construction. So you can see that we have all the equipment when it comes to geotechnical design. So for all your geotechnical problems, you can contact the CSIR BRRI, and we are always ready to provide your needs. You can also visit our website, that is www.brri.org, and you can see some of our geotechnical work that we've done for the various companies in Ghana and also outside Ghana. Thank you very much.